All right, so this first video, I'm going to finish the 4.3 notes where we stopped. So we looked at condensing them. That's where we're going to use these properties that you can see right here. And so we already completed the first page, so I'm going to scroll down. Okay, and I believe we already did 59, so I'm going to start at 61. And so here we go. So we're going to start by moving this back here, this back here, back here. So we're going to have natural log of x to the power of 3 plus natural log of y to the power of 5 minus natural log of z to the power of 6. And now if you want to, you can do this in 2 steps if you want. So we could start with this part right here. So this would become natural log of x to the 3rd, y to the 5th, minus natural log of z to the 6th. Now we'll condense this other part here. And so we'll bring this together, and our final results will be natural log of x to the 3rd, y to the 5th, all over z to the 6th. And that's what we're looking at there. All right. So moving on. Okay, if you look at 63, you have the 1/2 power there. There's a couple ways you can do this, but typically the easiest thing to do is to go ahead and take care of this part first and then deal with that. So this, leave the 1/2 there, so then this will become log of x times y. Okay, now we'll bring that 1/2 right here. So now you're going to have log of x times y raised to the 1/2. And then that's the same thing as square rooting. So we want to go ahead and do that. So we're going to do log of the square root of x times y. And that's what you're looking at on 63. All right, on 65, that one's a lot like what we just saw on 63. So we'll go ahead and take care of this part first. So you've got your 1/2. And let's see, we got log base 5 of xy. And let's see, then we've got, if you want to, we can already move the 2 here because there's not really anything to do here. So let's see, log base 5 of x plus 1 raised to the 2nd power. And then now we can move that 1/2 over here. And so basically you can see that you're going to get the same thing on 63. So I'm going to go ahead and write this as log base 5 of the square root of xy, because it's going to be the same thing that we just saw on that previous problem. Then minus log base 5 of x plus 1 squared. And then now we'll bring these 2 logs together as a single. So this is going to be log base 5. And so you're going to have the square root of xy on top, and then all over x plus 1 squared on bottom. And there we go. All right, so now moving on. At this point, you do need a calculator. You can probably get away with your phone calculator on this, but you can also download the graphing calculator you see me use in class. I mean, that's something free that you just need to go Google it, and you can find one of these, because that's going to be what I'm going to give you in class. So you're going to want to kind of get used to using this one. But like I said, if you don't have access to this one, you can your phone should be fine. If you have an Android, you can actually download this calculator on the Android for free. iPhone doesn't have this one, but you can get something similar to it that will basically do the same thing for you. Okay, so here we're going to do a change of base property. And so what's going on here is the calculator is defaulted when you press the log button, it automatically does base 10. And some of the newer calculators, you can actually adjust it, okay? But that's something that's only been around for a couple of years. Most of the older calculators are just, it's base 10. And so there is a workaround on how to do that. And so what you do, it's pretty basic here. You can either use log or natural log. But basically, on this example right here, you'd write this as log base 10 of 13 divided by log base 10 of 5. Okay, so your calculator should be able to do that for you. Okay, that would be the same thing as if you did natural log of 13 over natural log of 5. So it actually doesn't matter which one you do, it'll work. So here, I'm doing log. So let's see, log of 13, close the parentheses, divided by log of 5, and press enter. And so I get, I think it said 4 decimal places. So we're going to do 1.5937. So 1.5937. And so I don't want you to get, you know, when you're using the calculator, sometimes you're not really thinking about what you're doing. But I want to make sure you understand basically what you just solved. What you found was that 5 raised to the 1.5937 is about 13. Okay, so if I were to put that in the calculator, if I were to do 5 raised to 1.5937, it's not going to be exactly 13, but it's going to be like 12.999, something like, or I'm sorry, it was a little over 13. It was a little over 13 because I rounded up that 7 was a 6, and I guess it rounded up to a 7. So anyways, as you can see, it's 13.00, you know, so it's an estimation, but anyways, that's what the calculator is doing for us. And so it's solving exponents. And so that's kind of what logs are all about, is to solve for exponents. So anyways, I think I really probably don't need to do all of these. We'll do one more. I mean, it's very basic. This time I'll do the natural log, show you with the calculator. But it doesn't make a difference. So if I do natural log of 87.5 divided by the natural log of 14, I'm going to get, let's see, oops, let's move that over here. So let's see, natural log of 87.5 divided by the natural log of 14. And so let's see, we get 1.6944. So 1.6944. And so once again, what this is saying is 14 raised to this 1.6944 would give you about 87.5. It would be really close. So the main thing here is you can't mix and match. If you do log, it needs to be log over log. If you do natural log, you need to make sure it's natural log on top and bottom. And so anyways, I don't think it's worth doing a third example, but anyways, that's the end of 4.3. I'm going to make a short video of an introduction of 4.4 next.